So we have a problem with fractions in it, and it's important to remember that with fractions you get not only the division sign, really, but also there's like an implied set of parentheses around every numerator and around every denominator. So we have to start inside each set of parentheses and work our way out. So on the upper left, we got 2 to the 4th. That's 2 times 2 times 2 times 2. 2, 4, 8, 16. We've really got 1 plus 16 for our first numerator. Over here, we've got 1 plus 2 to the 3rd. That's 1 plus 8. 2 to the 3rd is 8. For the denominators, we've got 2 times 3, that's going to be a 6, plus another 3. And here we'll have 2 times 3, that's 6, minus 3. So these fractions are nothing terrible, really. We've got a 17 over 9, and a 9 over 3. Now, of course, when you add fractions, you do need a common denominator. For us, for this problem, it's a simple 9. So we don't even need to change the first fraction. The second fraction, we've got to multiply the bottom by 3 to make it 9, which means I better multiply the top by 3 to make it 27. Now that we've got a common denominator, we simply add those denominators, which is 44. And the common denominator of 9 can just stay. So 44 ninths is a perfectly acceptable answer. There's no way to really simplify that. If you want to write it as a mixed number or whatever, that's fine. There's nothing wrong with leaving it as 44 over 9. The second part of the problem says put some parentheses in there so that this expression is not 44 ninths, but instead is just the number 18. And now this does require some trial and error and maybe even some patience. There's certain places you can put parentheses where it won't make a darn bit of difference. For instance, no point in putting parentheses around there because it was already implied parentheses with the fraction bar. So let's put parentheses in there somewhere where it'll actually change the meaning. For instance, if I put the parentheses, it's supposed to be around the 1 and the 2. That changes stuff. So now instead of 2 going to the 4th, it's 1 plus 2, which is 3 going to the 4th. If I leave the bottom as 9, this would give me 3 to the 4th would be 3 times 3 is 9. Another 3 times 3 would be another 9. And all that multiplied would be 81. 81 over 9 would give me 9 so far. So if I can make this other fraction also equal 9, I'll have my 18. Check this out. Again, that's supposed to be around the 1 plus 2. 1 plus 2 gives you 3. 3 to the 3rd over, we said this denominator was 3. Would give you, for the first fraction, 81 over 9. For the second fraction, 3 times 3 times 3 is 27 over 3. Well, 81 divided by 9 is 9. And 27 divided by 3 is also 9. Together that would give you 18, which is what we're supposed to get. So our parentheses can go around the 1 plus 2 in each of the numerators.